Hey, and welcome to the Houdini for 3D Artist course. My name is Jason Slabber, and I'll be guiding you from start to finish in the creation of this epic cinematic piece. During the creation of this highly detailed looking environment, we'll be covering how to create complex looking geometry, dealing with packed primitives, various styles of instancing, and how to efficiently prepare your geometry for rendering, as well as setting up shaders and lighting. As this course is really designed for entry-level 3D artists, I wanted to limit the use of complex vex and wrangle setups by rather building our environment using Houdini's built-in nodes. We have to cover some basic vex though, but nothing too crazy. As well as using some VOPs, which is Houdini's visual version of vex coding. This is to cover areas where nodes just don't help us out. I'm really excited to get started on this one as we have loads of ground to cover. But before we start, let's have a look at an overview of what we'll be covering during this course. For week one, we'll have a look at the course overview, and that's what you're actually currently watching. Then we'll look at some reference and inspiration, and this is just important to help guide us in the right direction. And then after that, we'll look at some technical and creative goals. The main reason for this, we want to take a look at generating all this high resolution geometry, and we need to know how we can efficiently generate it. And not only generate it, we need to know how we can actually render it at the same time. Then finally, we'll be having a look at the project setup, and this is your directory structure, and things like your environment variables. We'll create a base shelf tool that we'll start adding stuff to, and then we might have a look at streamlining the desktop as well, just to make things a little bit clearer and less cluttered. And for week two, we're going to have a look at starting off with procedurally modeling this center platform here where this guy's standing on. And really what I want to do is work from the center of the scene outwards. And by creating this first component, we're going to be setting up some high resolution setups, and we'll use this to add to our detailing shelf tool that we're going to be building. And I don't really want to build a HDA for this detailing tool, is because it's going to be flexible, so we want something open that we can reuse and modify quite quickly without going to the hassles of a HDA. Then once we've done with this geometry, we're going to move on to looking at how we're going to actually render it efficiently in Solaris. So we're going to create a proxy display and then a render geometry side of it, and look at setting up the naming correctly and export that as USD directly from SOPs. And we also then want to, once we've got it into Solaris, we're going to have a look at creating a basic Megascans shader HDA. Now this is really something I wanted to do just from a Material X point of view, and we create this HDA which allows us to point to the directory of where the texture is, and we can just, with some really basic Python, we'll update the directory paths and build this little Megascans shader for us on the fly. So this just allows us to not have to go in all the time and update texture paths manually. For week three, we move on to the main walkway setup. And this is where we're going to generate a lot of these walkways, especially just to fill out the larger part of the environment. And I wanted to find a way to quickly generate these just by drawing some curves. While we're drawing the curves, we wanted to actually automate as well where the stairs happen. And this is really based off the angle of the curve. So if the angle of the curve is going above a certain angle or below a certain angle, then we automatically just generate these staircases. And this allows us to efficiently and quickly generate them without manually going in and selecting objects. For week four, we're going to build a base walkway HDA, and this is really taking the stuff we did, the setups in week three, and encapsulating it in HDA as a starting point, and then we're going to build on that. We'll generate some render ready instance geometry, and these are these kind of pavers that I want to build around the edges and the tops and the sides of the whole setup, and we'll look at how we're going to actually instance those on without overlapping the geometry. And to do that in quite an efficient way is to instance them onto primitives rather than to use copy to points and try and scale the ones individually. So you basically scaling them to the primitive size of the walkway geometry. So it's just a different way of actually instancing geometry that we're going to have a look at. For week 5, we will continue to develop our HDA further by adding some archways and some bridges. And these are going to be group-based selections, and we'll look at how we implement that at HDA level. And then we're going to obviously just finalize some things on the HDA, make sure it's render ready, get our names correct, and then we'll export this setup to USD, take it into Solaris, and check that everything's rendering properly and our proxies are working, and we can look at assigning some shaders to the setup. In week 6, we'll take a look at generating some of the other assets, and what we really want to do is build on some of the setups we've done. So we'll have built our little detailing setup earlier on. We'll modify that along the way once we start doing our pavers and our detailing for our stairs. And we're going to take those setups and reuse a lot of them to generate some of these big side pillars and the background walls and stuff that aren't really the focus of the setup, but we want to generate them anyway, and we need to do them as fast as possible. So we're going to be looking how we can quickly just, add some shelf tools and rebuild those setups quite quickly. And then obviously we'll export those as USDs and then make sure they're render ready as well. For week 7, we're going to switch gears a little bit. And this is our Copernicus week. Really exciting to have an opportunity to work on this new set of COPS tools. We're going to have a look at the basic workflow, how to pipe things together and, mix noises with your different blend nodes. And we'll look at importing some geometry, rasterizing that, and also some attributes and how we can actually utilize that to create some extra interest in our textures. Then we're going to move on to obviously piping it into some shaders, and we'll have a look and see how we can render this in Karma and getting the most out of the detail by setting up the correct parameters. So looking forward to this week. It's going to be quite a fun one. Then in week 8, we'll look at finalizing our setup. We're going to be importing our animated characters and cameras. These are all Lembic files that have been animated in Maya, and we'll look at how we need to import those into Solaris. And then we'll finalize some of our shader setups, and we'll start looking at some nice lighting, and we'll take a look at some of the shots as well and see how we can change the lights based off the angles of the cameras, and to make things look good from each camera view. And we'll look at some render settings to get decent results out of this setup. So that's the basic overview of the course. Some things might change a little bit, just to give you a bit of a heads up. So if this doesn't follow the exact route, don't be concerned. We will be covering everything that's here, but it's just we are recording this as we go. So sometimes things might swap around a little bit here and there, but to the most part, we're going to try and keep it as rigid as possible and to stick to the structure. But like I say, we will be covering the entire setup and how to create the visual that you see in the trailer. So let's just move on to one or two other little things. Okay, moving on from the weekly overview, just a couple of extra things I wanted to cover here. And that for one is the Houdini version. So I'm going to be using Houdini 20.5 for this training session, and I'm on an educational license. The project was actually set up in Houdini 20. So if you've only got access to Houdini 20, you can still complete this course. Now, that would obviously mean that that Copernicus week that is specific to Houdini 20.5, you won't be able to do, but the rest of the course is definitely achievable. Then we've got Side Effects Labs that generate some really nice little tools for us and make our lives easier. So please make sure you install that when you installing your Houdini. And for my reference and inspiration, I'm using Miro boards. I find this is quite a nice handy tool. It's quite dynamic and easy to add images, just drag and drop images or videos to, quickly to add boxes around it and add titles, etc. Just a nice tool, and I do use the free version, so it gives you 2 or 3 boards, just quite handy. Obviously, you can choose whatever reference method you want to use, but this is the one I'll be using throughout the course. And then on this side, we've got Quixel Bridge, and we're going to be using the Megascans textures for our shaders. And I'm actually not using the Houdini plugin. But what I found is that, well, sometimes it's quite tricky to get it to work with the latest version of Houdini, but also it generates a principled shader for us without much control. And what I wanted to do was build a custom shader HDA, and I want to use Material X so we could, so possibly generate some calmer XPU renders. And then we also wanted to have a little bit more control over our shaders and, be able to adjust things. So having our own custom-based shader that utilizes the Megascans textures is what we're going to be doing. Now to do this, we're going to create a short little Python code, and it's a very simple one, so don't worry if you're not a coder. I'm not a coder either, so it is quite a really straightforward one, and it will give you quite a nice insight to actually how easy it is to generate a simple little setup that we're essentially just calling the path to where the texture is and then populating the shader based off that texture path. So quite a handy little tool, and it's just going to allow us to create, shaders a little bit quicker. And then lastly, we've got our Discord channel, obviously, and that's going to have a dedicated channel to this course. This is obviously me on the side, Jason_Slab, and then we've got Gavin and Andrew, and these guys are our training assistants, so really good guys to ask questions. They're really helpful, and but feel free to add us anytime. Just keep in mind that we are all in different time zones, so we might not be able to reply too quickly. And then just on the note of asking questions, you can also look, we always do a little pinned bar at the top of the course channel. So check that if you've got some questions, they might have been answered already. Otherwise, yeah, just feel free to at us if you can't find any help on the channel, and we'll gladly assist you. So looking forward to meeting you all there, and let's get ahead and start with the first week. Hey, and welcome to week 1 of the Houdini for 3D Artist course. What I wanted to cover just first briefly was this first week we just really looking at concepts and some technical stuff. So overall, when I'm showing you stuff, obviously you don't have to follow along, but at the same time, some of the stuff might look quite overwhelming when you're first looking at it. If you're not very familiar with Houdini, then it's going to be quite overwhelming. But don't worry, when we get into the actual creation of the content, I'll be taking you step by step through that. But if you really haven't used Houdini before, what I would suggest is having a look at this fundamentals course, and we've put up the first 3 hours of this course for free. And there's quite a lot of stuff covered in it, but just going to hit play in the first part. Once we get through the introduction, this is talking about the course as a whole, which you shouldn't be concerned with. But over here, in this next part, we start looking at the project and desktop setup. Now, I'll be looking at this type of stuff in this week, so you don't have to really worry about that too much. But then going on to creating some basic geometry, this might be quite nice to use if you've never used Houdini before, and just help you understand where to get started with Houdini. I'll try and start off slow with the course, and then we're gonna pick up the pace as we go. But yeah, if you really haven't used Houdini, then I would suggest having a look at some of this. You don't have to watch the entire thing, like I say. Just some of it, just to get the gist of, the Houdini flow and how to navigate around the viewport and stuff like that. It's just quite, it's going to make your life a little bit easier as we go into the next weeks of this course. So moving on then just to the basic overview again of what we're covering this week. So I want to have a look at my referencing, and for this I'm using my Miro boards. And this is just going to, obviously, as it says here, help us achieve our cinematic vision. And then we're going to go on to the bigger part of this week, and this is where I'm just going to take you through some of the concepts of how we're actually going to build this project at a large scale with the high-res detail geometry and some of the technical kind of difficulties that we want to try and break down and simplify, so it's not overly complicated for us to achieve. And then obviously we're going to look at the rendering side as well. And then the last part of the week is just, setting up the actual project. So we've got all our stuff in place that we need, looking at our frame ranges and stuff like that, creating a basic shelf tool. I've also added the recipes, which is a new thing to Houdini 20.5, and we could add those to the shelf tool if we want to, but it's also quite a neat tool set to be able to utilize. So we're going to have a brief overlook at the recipes, and then just some basic stuff of refining your desktop a little bit, just to clean things up and help remove some of the extra clutter. So with that being said, let's get started with the first part, and that's having a look at our reference and inspiration. Hi there, so just covering the reference part of the course here, I just wanted to really take a dive into what I generally use to gather reference and some of my thoughts behind that. So what I like to actually use is Miro boards. And I actually used to use this in production quite a bit. It's really handy. You can collaborate with multiple people, and multiple people can upload things, and you can organize it that way. But even just as a single user, it's really useful to keep stuff in the same place, and you can categorize things and put them in frames and scale them up and down and stuff. You can add, titles to it. Break it up into different sections like I've done here. And what's pretty neat about it is you can upload files directly from your computer, but you can also copy stuff directly from online. So for instance, if we have a look at this ArtStation graphic here, I can basically right click on it and I can say copy image address. I can go to my Miro board and I can Control V here, and you'll see it pasted quite big, and I can scale it down and move it to where I want it. And you can do this with videos as well. So I've got this Diablo, which was one of the main references. I'm going to copy this URL, and let's just Control V to paste it, and you'll see now we have it actually in here, and you can play it directly in the board as well, which is quite nice to be able to do. And you can see, this is, have a look at this video. The link should be in here. It's pretty cool. This is kind of the main reference what we went for. So going on to this side here, you can see some concept art from the actual game cinematic, and here's some screenshots here. Some really nice moody lighting, and you've got the center structure with these archways, and so kind of mimicking this in what we did. And then we've got some other references, and I guess just on the subject of these references, I'm just gonna go ahead and move these out the way for now. What I like to do is I generally collect a whole lot of references in the beginning and just really flesh out some ideas and different styles, and see what I really like and what really starts coming together, start trying to piece together a look. And then once I've done that and I'm actually started on the project, what I like to do is come in. As you can see, I don't have a lot of references here anymore, but I actually come in and delete some of them out, and You could probably move them to the side, but I try and commit to it and delete the ones I don't want. And the reason for that is I find often, when you're like 2 weeks into a project and you're looking at a specific style and going, oh, this is the direction we want. But then you might one day open up your references and you see this other image on the side here and you go, oh, that's actually really nice. I should follow that. And then you start changing direction, and that can lead you down a rabbit hole of a whole different big change. And so especially something like this, and when you want to really get focused, it's nice to minimize your reference to a certain point and try and keep to the styles you want. So we've got this main style here, and there's the ones that are left is just some really nice. I love these kind of break up on this paving and these little fire pots here with this sort of cyan fire and the volume lighting coming in. It's really nice and pretty. Same with this, some nice volumetrics with this shadowed or this dappled light coming through. We wanted to achieve that. And this is kind of, I guess, similar to the bottom one here. This is just kind of looking up. It's quite a nice graphic, and also got this kind of dappled light filtering through with the bit of oranges and stuff. It's really nice. Then I just kept this one just a bit of interest. It's got some nice rays like this one as well. But yeah, this is a bit of a different look. So this is kind of something that I would probably end up deleting out. And then just moving on to some extras. So we've got our design ideas. I really love the kind of structure of this. You'll see it in my center column. We've got this, nice, quite square layout, and then you've got the stairs coming down with a smaller platform up to the side. And yeah, it's nice to see this graphical drawing stuff as well. It's a bit of inspiration at the same time. And then, yeah, we've got some sides of the walls, some pillars, ideas and stuff we can look at. This one was really nice as well. Just wanted to keep this here. Like this circular look with this, stepping up to the centerpiece and these nice big statues here. Quite a nice look. And then just moving on to your pavers and styles. So there's a bunch of reference here. And after some kind of really looking around, and you'll actually see it over here, this paver here is this one. And I really love the style. It's quite graphic. It's obviously not 100% realistic, but it lends itself to that sort of game cinematic feel. And so what we did is we wanted to create this. So I tried my best to recreate this in 3D, and then we still wanted to just add realistic textures. So we're using Megascans textures, and I'm just applying those Megascans textures on top of this style of paver. And it gives you that interesting mix between, stylized and realistic. Just some more variations, with some decals and stuff in the middle, and some really nice ideas. Yeah, I love this kind of staircase system here with the edges and these pillars, and we've got the rough pavers here, which you can imagine them being these ones. So it works quite well. And then, yeah, some statues and stuff like that. Nice circular pattern over here. That's really nice. And then moving over to this side, we've got some more kind of textures to look at, nice, quite 3D stuff here. And then some realistic stuff is always nice to have. Just the look and feel of how things kind of fall off naturally. I love this stone here that you can see, like the clear stone, and then they've kind of patched in the concrete like fillers here, so it looks quite like, it's white concrete, and it fades off up to the higher parts of the building. Some nice erosion happening everywhere. And then this one is quite different, but yeah, this like slate stone that's broken up and some greenery in there is quite nice. And then, yeah, we've got down at the bottom here, I've got 2 or 3 ones that I've added. I've taken another one out, but this was added a little bit later. This is, starting to look at the Copernicus type workflow. These are Substance Designer setups, and we wanted to try and, mimic these bricks and see how far we can get to kind of creating these nice bricks with this chunky looking screed or cement squelching out. So such a really nice look. And then, yeah, this one pavers with some dirt in between and stuff like that. So trying to achieve this as a texture-based system is one thing we'll be looking at. And so we're just going to keep that in the reference section. So on this, note that, yeah, I'm exporting this Miro board as a PDF, and this should be available for download if you just want to quickly reference that. But yeah, I would recommend trying out Miro. It's really nice to, to gather your stuff, and you can have, this is a free version. You can actually, if I go here to the main page, you can create, I think, I'm not entirely sure, I think it's like 5 boards or something on the free setup. So you can have different setups and, name them and add thumbnails to your setup, and it's quite useful. And then you can also obviously share it with other people if you wanted to. So yeah, let's move on from the reference, and we can get stuck into looking at some of the technical sides of generating, all this data, these large scale walkways with all this paver detail in, and it's like some really high-res mesh. So we'll be looking at that next. Hi, so having a look at our technical and creative goals, what I've done is I've opened up a scene that I've created for the trailer, and I just wanted to start off by showing you the overview of the actual scene that I've built and actually how complex the geometry is. And then I want to take you through a walkway setup, and then we're going to start breaking down how we can actually achieve and go behind my thoughts of actually building these walkways specifically. So having a look at this, this is just the walkways of the scene. I've got some missing arches and the roof and all that kind of extra detail in the center structure. But what you'll notice is that there's a lot of these gray boxes, and if you're not too familiar with Houdini's packed primitives, this is a detail optimization, and this just allows us to pan around the viewport. So as you can see, as I'm zooming in here, these little gray boxes are disappearing, and I'm actually getting left with geometry. And if you look at the detail on the geometry, if I go into wireframe mode, you can see there's quite a lot of information here. And even though these pieces of geometry have been poly reduced and optimized, there actually is tons of geometry. So to give you an idea of how much geometry, so if I go to D on my keyboard to bring up the display options, and I go to the last optimized tab, is this distance-based geometry culling, and my scenes limit is set to 50 million. So that 50 million is the entire scene, so obviously would include these bounding boxes, but it gives you an idea of where I'm starting to actually cull my geometry. Is, we got super high res and a lot of geometry that we're dealing with. And like I say, this isn't the entire scene, this is just the walkways component. So over here you can see there's the main walkways, got upper, mid and lower walkways. And then I've got all this other geometry that's hidden. And off to the side here's some additional setup stuff that I've done. And here's my statues and stuff that's been hidden on this side. So that's yeah, exactly what we want to try and achieve. We want to try and achieve as much detail as possible. And the idea and the thinking behind this is, let's say we need to build this scene and this environment based off one of those nice concept art drawings we've had a look at. And we need to get going, and animation and camera work and stuff hasn't been done yet. So what we would like to do in this case is actually build geometry everywhere that's high res, so we can come in and explore our camera work and our characters at any point and just have a go. Okay, this is a nice angle. we can come in here and, explore this area, and we have high-res detail wherever we go. So there's no building the scene around where the action happens to say. We can just go in and come in afterwards and just place our cameras and build the animation wherever we want, and the scene should hold up to that level of detail. Now that obviously opens up the problem of having this level of detail everywhere, and that's why I chose this method of actually creating these pack primitives that represent almost, you can imagine like tiles. You can see they popping on, go out of wireframe mode here. As I kind of zoom in, they pop in and you can see these bounding boxes happening, and that's like each one of these pavers is actually, you can see them as like tiles, and they're scattered along the surface in a way of the object. And the same as the sides, you can see there's tons of objects here that's been scattered over. And the idea here obviously is then we've got a couple of variations of each one, and these are randomly rotated by 90 or 180 degrees, and then we can just instance them across the entire surface to create a really optimized workflow. And this will allow us to really reduce our render time, RAM usage, and stuff like that. So quite useful to be able to generate all this data and still be able to render it from any angle we want to, which is quite ideal. Another thing you'll notice while I'm panning around here is if I zoom into this pillars area, let's go right in, and you can see, okay, we've got quite a nice little bit of detail here, but you'll notice there is like a double geometry here. If I go into wireframe, maybe that's a bit more obvious. You can see these almost low res pieces of geometry here. These are actually my Solaris proxies, and those are what's going to be displayed in Solaris when we go into the Solaris level. And then this high res geometry is what we're actually rendering. And for this visualization purposes, I've just enabled the render time Solaris setup so we can have a look at it. But obviously when we're working and setting up the shaders and the walkways, we don't want to view this high-res geometry as such. So these are actually using the USD proxies as a display option, and then we've got our USD render times when we export to USD. So I just thought I'd show that off. And then what I want to do now next is just actually go through how we generate the walkway, just show off the actual tool that we're going to be building, and just how how interactive it can be if we optimize the mesh enough. So moving over to this side, I've got a walkway example here, and I'm going to just dive in there and start creating some piece of walkway, and we can have a look at that. Okay, firstly, I'm just going to hide all these pieces of geometry here. Just disable the display flag, and I'm going to go into this walkway example here. You can see I've got an error on my HDA. I haven't built in any kind of error functions here, so but it doesn't matter. It's just because my curve I've reset. So what I want to do is draw a Bezier curve or a polygon curve. So if you just drop tab and type curve on the keyboard, we can do a curve here, a polygon curve, for instance, and drop that in. Let's plug that one in, and then we can go ahead and draw our curve out. So let's just switch my display here to the stairs, walkway stairs. I've got on the second input, I've got a grid, and this is actually grid's been transformed down a little bit, and that's essentially what my floor plane is. So for this instance, I'm creating my walkway at the origin or the grid level, so ground zero apparently, and then we can project the rest of the walkway down onto that. So let's just start out here by drawing a quick curve. So I'm going to hold down shift and draw my curve so I can draw it in a straight line, and press enter, and enter again. Let's just add 1 or 2 extra points so we can maybe do some stairs going down. Let's do another corner here, go here and make another set of stairs going down, maybe a platform, something like that. Just keep it simple. And you can see that generates fairly quick. And like I say, here's my ground plane. I can adjust the height of, and we'll have a look at a little bit more at that in a moment. But going back to my curve, so let's have a look at these stair areas. So the idea behind this was to be able to, like say, create these stairs based off curve angles. If I, for instance, select 2 of these points, let's hit Y on the keyboard so I can get to my gizmo here, and then just start dragging them down, and you can see beyond a certain angle I get this instant stair generation happening. So it just helps us, automate a few little things so we don't have to go in now and, manually select this group and apply a stairs to it. It's just wherever the angle is happening, we've got these stairs. And maybe we can add some extra ones here. Let's do something like that. So we're stepping down into a lower area. Something like that. It's kind of working good enough for this example. And then just looking at the walkway HDA, there's a couple of things that's been exposed. So we've got, I've got this little simple view. I'm just going to go into wireframe, doesn't display so nicely, but that just gives us the kind of top surface. And so if we've got a lot of walkways, we can just display this and draw our walkways, and it's even quicker to utilize. And I've got some main curve setups to resample the actual curve at the top, and you'll see everything gets tightened up a little bit more. But what I want to try and do when we're doing this walkway is try and keep these polygons almost, a little bit more uniform, because we're going to be treating them as almost like little tile pieces of geometry. And we can adjust the width a bit, scale this up and down, and then we can also add some noise to the actual walkway width as well. So we've got a noise size, it can increase the noise, and so just adding a little bit of extra edge to it and giving it a slightly more natural look. Just adding a tiny bit of noise in there just helps us. Yeah, so it's not so uniform and constructed. Then we've got the tops and sides. I've got these little drop downs that you can build, and the tops and sides are really just quite simple. This is just allows you to preview the surfaces. So if I preview the tops here and you give it a second to cook, it doesn't take too long. And there we can see now we've got these tiled pavers happening across here with some extra detail in between. And these are going to wireframe, my packed pieces of geometry that are scattered across this top surface. Likewise, we've got the sides, and then I've got an edging as well. So we've got this low res edging, and give it a second, and you can see now I'm viewing the edging. And these are all kind of treated in slightly different styles in how we actually get to scatter them and copy them across the surfaces. So we'll be looking at all those kind of stuff. And then it's just disable our tops here. Then we've got this archways. And this is, I chose to do like a group-based selection. So you want to do really isolate exactly where you want these things to happen, instead of them, generating them automatically. We could do that randomly, but then, that becomes a little bit, you want to art direct the walkways as much as you can. So for instance, I want to, have some archways, maybe, let's have them along this side, and we can just select the group, just select a couple of polygons here, and press enter. And then when I enable my archways, I get my little proxies, and that pops up, and we can actually scale these up, and what happens is it actually scales the walkway between these two areas, and it will, you can obviously go quite low and it becomes a bit messy, but this allows you to keep the spacing between each one the same and just controls the overall scale of everything. And what you can as well do is just, the preview is quite quick as well. If you're actually just looking at the mesh, and you can just scale it up and down a little bit too. The other nice thing about it is these archways are stuck to the ground plane. So if I move this ground plane up and down, my little columns, they actually just extend outwards. So you get this quite nice long kind of pillars quite easily without trying to, figure out a different method. And you can see they are little sections, and I chose to build it like this specifically. You can imagine like an old pillar that's kind of starting to crumble, and you would, in the old days, they would kind of build these in sections almost, and then put them together like this. So you've got these kind of like areas that are built on top of each other, and it creates like a slight little bit more breakup and a bit more interest. And yeah, so that's the archways, and then let's just disable those, or we can disable the scale them up a little bit again. And then we've got these little bridges as well, and we can put the bridges anywhere, but for instance, let's just tag these stairs here, and I'm going to press enter on here and then just enable the bridges, and this creates this bridge geometry. Again, you can turn on your visualizer, and this will use the same setup as the side walls, but it just uses a slightly different approach that scatters the geometry and deforms them along the curvature of the bridge here. And you can obviously adjust the bridge curvature to exactly how you want it. So that's quite handy. And then just moving down to the stairs, or up to the stairs, should I say, we can just expand this. We can automatically scale the amount of stairs. And what's quite nice about what's happening here is, perhaps if I look in wireframe mode, it will be easier to see, but we're scattering these stairs based off each one size and the angle that it's sitting at. You'll always get, your stairs will be kind of at a correct height and according to the amount you're scattering. So they never really offset, they always kind of in the correct space, as to say. I've got a little bit of a rotation offset you can see happening as I'm kind of going through here. So they're not entirely even. This is obviously viewing the proxies, and then we can actually view the actual stairs, and you can see this is actually quite quick to set up and do. So quite handy. And then we've got some stair variations as well. There's you might want to control this. This will obviously be a little bit quicker to copy if you're viewing your high res stuff, but ultimately you want your maximum amount of variations you can generate. I think in this case I generated 14 or so. So if I go above a certain amount, you can see you start getting spaces. So they've got 16, and that's 16 variations of stairs scattered throughout the entire setup. Others, maybe it's 15. Yeah. And that gives us a fairly decent amount of variation. They also rotated 180 degrees randomly, just to help us give us extra information. And then on the stair sides, we've got an option to switch them to this balustrade setup. And this just allows us to create a little bit more extra variation between the stair types. So turning off my preview to make it quicker, so we can see we've got two different variations, just to show you how easy it is to add extra stuff to it. And then obviously we can change then the amount of in between scatter pillars we've got as well. And that's really what I wanted to show as far as the actual setup and how it is to kind of work with it. As you can see, it's fairly quick to, manipulate. And, when you're starting to build a whole bunch of stuff, it's quite nice then to have this level of detail to just visualize and be able to set up something and change something quickly without the slow update. And the nice thing as well, what we can do is we can develop one HTA. You can, for instance, in my setup I created like a multiple stair setups. And what you can do then is just create, for instance, let's clear this out. You can create another curve here, say. Let's just ghost this. And then we can, start working here and creating some more stairs going outwards. And when we, as we're developing this one and we save it, it will kind of give us our new set of walkways without really, having to rebuild them all the time. We've got just one HTA and you save that HTA, and then as you update it, this little extra, one you've created will update accordingly. You will have bug fixes along the way that we've got to fix and stuff like that. So quite handy to have. Next, I want to go through and discuss the problems that I ran into and how we're actually going to go about and scatter our packed pieces of geometry across these surfaces in a decent fashion. Let's have a look at that next. Okay, before I go on to the issues that I had setting up the walkways and how we're going to resolve that, I just briefly wanted to cover some pack geometry if there are any of you that are unfamiliar with the workflow and what pack geometry is. So I've got a really simple setup here I've created. So I've got this grid with quite a high resolution. You can see we've got quite a bit of geometry going on here. And if I middle mouse on it, you can see there's 40,000 points, 39,601 primitives. And what we can do with this is we can actually pack it down into one piece of geometry essentially. And this is like, I guess, putting it into a suitcase. And yeah, if you zoom in onto this icon, this packed icon, you can see it's got a little suitcase symbol, so it fits quite well. So now if I click and view this, you can see we lose the wireframe detail, and that's just because the pack primitives don't display wireframes. If you go into wireframe mode, you will still see a wireframe, but the pack geometry doesn't actually give you point selection or anything like that. And if I have to middle mouse on you or press the information, you'll see now I've gone from that 40,000 points down to now I've got 1 point and 1 primitive. And that means that this geometry is now, I can transport it around, I can move it around as one individual piece without distorting it. I can't select individual parts of it until I unpack it again. So what I might want to do is maybe move some stuff around with a packed piece of geometry and then unpack it again. There's quite a few applications you can do with it, but one of the big things is to use it for instancing. Just to show you what you can do. So if I've packed it, you can then obviously, I say unpack it again, and that takes it out the little suitcase. So now you go back here and I've got my original point count back, which matches up with this 40,000 points, 40,000 points. And in between, I've got a pack. So the geometry hasn't changed. I've just taken it in and out my suitcase. So if we got a packed piece of geometry, what can we do? So we can obviously efficiently now copy it. So I can, copy this a whole bunch of times. And if I, go to maybe 10 copies, if I information on this now, you can see I've got 10 points, 10 primitives only. If I had to unpack this now you can see I'll have 400,000 points and a whole lot more primitives. And that's now because this is seeing this as one complete piece of geometry rather than a whole bunch of suitcases of geometry, I guess, stacked next to each other. So that's just something to be aware of. Was quite handy with having it packed like this, even if it's just not for instancing purposes. You can modify some stuff. So maybe you want to move things around. Say in this example, I've got a mountain top, and let's just make sure we're still packed. So we've got our 10 packs. You can, by the way, on the copies, you can pack an instance. So if your geometry is not packed, you can pack it there as well. It's exactly the same method. So you'll see 10 instances there, and if I unpack it, you get the same result back. So we can do that way. And then now that we've got these 10 pack parameters, I can attach a mountaintop pretty much like I did here, and you can see this distorts the whole grid. So if I adjust any of the values on this, we've got, these points all distorting. But now if I apply it to my packed pieces of geometry, essentially what's happening is it's not modifying the geometry at all. If I modify this geometry, you can see that I'm modifying each one. But if I move this ramp or this mountain that I've got going here, and I adjust the size, you can see it's actually only affecting each essentially packed piece of geometry, and that's basically taking the point. You can see if I turn on my point display, you can see there's only one point here, versus if I had to unpack it, you'll see I've got points everywhere. So now what I'm doing essentially with this mountain top is I'm applying a noise just to each of those points, so it shifts all of the things around. And then, for example, what I've done here is there's this amplitude scale, and I've set the value to 0 on all the axes except this one. So I'll only get an offset this way, and then there's the amplitude we can adjust it by. So that's actually quite handy. We can adjust the noise size, and then we can get a lot of variation in things without actually having to try and compute and do it with the actual unpacked geometry, because that would be quite hard if you wanted to achieve the same goal. If I put my noise here now, you can see, for instance, I'm getting this completely distorted setup as each point is getting the noise applied to it. So just quite handy to be able to do stuff like that. And just moving over to this side, I've actually imported one of the pieces of geometry that I've created for the trailer. And let's just zoom in on this. Now, you'll see looks like a whole bunch of geometry. And you're right, if I go into wireframe, I've got a whole bunch of stuff over themselves. So what I'm actually doing is I'm saving out a whole lot of variations of this. So if I middle mouse and get my information, I've got 10 pack primitives. Now, in fact, this is set up for rendering in Solaris as well. So there's actually double geometry. So if I go here and I delete my render group that I've created, I'm just left with the render geometry. So then that's half the amount it's packed primitives. So if I go here and delete selected, this is actually my proxy display geometry. Let's just delete out one so we can have a visual on that. And you can see, in fact, this is a low res piece of geometry. Deleted the one slab, or the slab 0 with this name attribute. And if I go to this one, you can see this is the higher res geometry that we're using for rendering. So those two have identical names, and they're just packed on top of each other. So I just wanted to just point that out just to avoid some confusion here in this example. But what we can do is just show you an example of how we can deal with pack geometry. And we've got obviously a couple of pack pieces here. So for the moment, what I've done in this simple example is just wanted to show you the difference between the performance of packing and unpacking. So I've got a simple grid here. Zoom out, I'm scattering some points along it and then doing a copy to points. And what I'm actually taking this one piece of packed geometry, I'm unpacking it so we get the full geometry back. And then I'm scattering it around on this copy node. So let's just go out of wireframe mode. And now what I want you to take note of is I've got this FPS set up here. If you go to, I'm hovering over the viewport and I press D, that brings up the display options. And under the guides, there is a draw FPS time. And this will give you your playback time. And as well as every time you cook a node, it kind of gives you a display of how many frames per second it's showing. And I just wanted to add this on because it's hard to, I guess, visualize to a certain point of, you know, when you're recording a video to illustrate the usage of what's going on and just to make it a little bit clearer. So if I take my count at the moment, I've got 43 points here that I'm copying to. So essentially what I'm ending up with is this, you know, it's like, yeah, like 1.2 million points already just for this. And what happens if I reduce and increase the amount? So that's not too bad. And if you look at the frames per second here, you can see as I'm sliding, things are really starting to slow down drastically. And I'm lagging here quite a lot. And, you know, we've got 231 points here that I'm scattering this geometry onto. Middle mouse here, you can see we've got a whole lot of geometry. It's like 6.5 million. Not a crazy amount of geometry, but just really not efficient to be able to, you know, copy. And then what I wanted to do is go over here. Let's just reduce the value again down to like 30. And then I've got a little switch here, and that's just switching back to my pack primitive. So now I've got my pack primitive instead of my unpacked one. That's coming in. I've got 17 points here now. And then taking note of this FPS now, I'm going to bump up the value, and you can see how quick I'm running. You know, there I'm hitting that 100 already. I'm going up to 1,000. You can see my display is actually starting to limit out to that 50 million polys. And yeah, I can go all the way up. I mean, I can go to, yeah, I've got like 100,000 copies of this piece of geometry. And I can, you know, it's a bit crazy, but I can zoom right in and you can see we've got this geometry and it's completely overlapping. So that's really how efficient the packing is. It just allows us to take geometry to the next level, and this is kind of referred to as your packing and instancing. So we've got pack and instance, which you can use here as well, but at this moment I'm using it just to pack geometry, which is the same thing. So it's taking each one and instancing it onto the point rather than copying the whole geometry on. Way more efficient. So yeah, this is definitely the best approach for a highly complex geometry to be able to do. What you can also do is you can actually take variations of this. So as I mentioned in the beginning here, I've got my 5 different pieces of geometry. They all the same size and they just random variations of each one. And to illustrate this a bit better, I've done a color on it. And I've said because it's packed and I've chosen random color, so it's going to randomly color each copy. And then what you can do over here, you can actually use a attribute called name, and you can create a variation that's set up here, and you can then adjust your amount of variations you want based off the amount of copies you got. So I've got 5 different variations that I can scatter randomly across this surface. So now we've got, instead of just one copy, we've got 5 different variations of that copy. And this is a lot more obviously efficient, and it gives us the ability to instance, just a couple of pieces of geometry and create a lot of variation very quickly. Like I say, we've got this, and then we've got, you can randomize the scale of each one and do all the normal copying stuff, with the ability to have variation in them. So hopefully that gives you a little bit of an understanding of the pack primitives and their advantages. Let's move on to some of the technical difficulties with creating this walkway. Okay, taking a look at some of our challenges we've got ahead of us in deciding our approaches. I've got this little copy example set up here, and just to illustrate, we want to try and think of ideas how we're going to copy the geometry across the top surface of the walkway, and then we can progress to the sides, etc. So first of all, let's say we've got this grid, and imagine this is our walkway top. We want to be able to scale it up and down. Obviously, this is simple. We would want curves, corners, and stuff like that, and how we're going to deal with that. But I've brought in my little packed piece of geometry again, just deleted out the proxy stuff again, and then just isolated one. So first of all, we've got this straightforward copy, and we can obviously try and do a bunch of copies like this, and then we can control the spacing to get them to like overlap and line up, and then we could get the next line and try and copy that way by rotating stuff. We can also rotate stuff at like 180 degrees. That will give us some extra variation, but obviously this isn't really ideal for a larger scale system to be able to do that, because you're going to end up doing a lot of work copying stuff. The other option is our typical copy to points. So I've got my grid here. I've just added some normals just to give my orientation correct. And then there we've got the copy to points, and you can see that works well. I mean, that's obviously great. It's fast and it's working. We would need to obviously now, if you think about it, compensate for the amount of copies as the walkway gets longer and shorter. So we'd have to try and deal with some kind of expression that would even these out as we stretching them, and that's possible, but it's also not ideal because we want, for two reasons, we want corners, and also we've got a walkway size. So imagine this is our walkway size, and what we want to be able to still do is add detail edging, and we want to add sides that go downwards, walls that go off to the sides in our stairs. So now we need to, if we're copying to these outer points, we need to try and somehow compensate for that. And that's not really going to be a very easy thing to achieve, because now our walkway is actually essentially much wider than the grid, and we'll have to then try and build our outer walls from the boundary of this, and it just becomes quite a lot more complex. Now there's another option, and quite an easy one, to get the grids to fit a little bit better within this space, is we can actually convert each of these ones to a point, get the center point of each of these primitives. And to do that, I'll show you a quick setup. It's not the most elegant solution, but it's quite a common one. So we can do a primitive split, and this will give you an error straight off here. It's got this name attribute you just need to disable. And what will happen is, if I view my points here, if I zoom into the point count, you'll see I've disabled it. I've got a point there, if you can see. I don't know if you can see it clearly on the recording, but there's a single point there. And if I enable it now, I've got a bunch of stuff that's overlapping. So it's basically splitting each one of these primitives out into its own primitive rather than a joined primitive. And then what we can do is we can do another operation called primitive properties. And let's just view that. And then on this primitive properties, we've got a transform. We can enable this, and then I can scale down each primitives. And as I do that, you can see it's individually scaling down each primitive. So I'm just going to ghost this or reference this top grid we've got going here. See if we can scale it down, and that's quite nice. And what you can actually do is just scale it down to 0. And now I've got effectively my center point. However, I've got all these 4 points now as one, in one center point. So that's not ideal. I've got now 80 points from my 20 primitives. So that's not ideal. So let's fix that. We can use what we call a fuse sub. And I'm just going to drop this. And then what I want to do is, you can see at the moment it's giving me no points. And by default, what it's doing is it's actually using a snap distance, which is fine since our points are all on top of each other. But there's some options down here, and this one, remove unused points from degenerate primitives. You need to just disable that, and you'll see we'll have now our points back. So now I've got 20 points, no primitives, they're just points now. And that's just because I've fused everything. So we've gone from 20 primitives to 20 points, and they're at the center of each one of these. Now I can plug this into my copy, and bam, there we go. We've got our primitives all in the center of this walkway, and that's getting somewhere. That's a little bit better. We would still need to compensate for the scale and stuff like that, and how we deal with that. But if I go here and I make a couple of extra points, and we can start playing around, and that kind of works quite well. That's quite quick and fast, and the only thing is they don't 100% fit into this, so we need to figure out a better way to deal with that. Now, just before we get to that, I wanted to show you another possible solution, which is almost working, that I tried to set up, and that's using this chain sub. Well, the chain sub is really cool. It's got some nice features, but it doesn't work off points as such. It builds its own points internally, and it actually works off curves or lines. So I've got this line here. Let's just disable my reference here for my grid. So I've got this line here, and then I'm plugging in my pavers. In fact, I'm plugging in all the 5-packed pieces of paver, all my variations, and I'm just going to enter this and view it, and you can see immediately. Let's just go out of wireframe mode. I've got a bunch of pavers, and maybe we can do a color on this just to help visualize things. I'm going to set this to random, and you can see automatically, without actually doing anything, set this to default, I've got random pavers traveling along this line, and that's quite nice. If I scale the line out and move it back, it's giving me a really nice result, and really nice and quick as well. And you can do a couple of things, like I had this fraction length of the curve, and that kind of tries to fit it more to the end of the curve. You can go here to cycle, and that will cycle the offset of each randomized one. This is quite a nice start to something. We've got an offset here, and you can say piece spacing, so you can actually create little gaps between things. You can overlap them a little bit, so if you don't want any gaps. Some nice powerful features, and but this isn't entirely ideal for our setup, and I'll show you why now. So if I go and I want a corner here as such, or angle in the setup, I'm going to have to try and figure out a better solution. So at the moment, I've created this curve with this kind of almost 45-degree angle corner here, and then a straight end again. Just doing a resample node on it, so I've got a few more points in between. And then let's just plug that into our chain sub and see what kind of results we get. So now you'll see some interesting little issues, and that's really only on the corners. As the corners approach, the pavers start offsetting in a weird way, and you get these kind of strange little issues happening, wherever it's along a straight edge, this is copying perfectly. I mean, that's amazing. It would be nice if we could easily figure out why this kind of issue would happen, but it's still, I guess, not entirely ideal because we've got quite a lot of overlap happening between these areas, even if they were lining up. So what we want to do is we want to look at maybe even a different solution again. And the solution, what I thought about initially and then started to develop on, was using this match size node. And if you unsure what the match size does, is I've got this, my paver, and this allows you to, at the moment, I've just transformed it randomly into a different space. So it starts off at origin. I'm moving it off into a random piece of space just to illustrate this setup. Let's just create a new match size node. Sorry, I wanted to connect it in here, like so. And if I view it, you can see immediately what happens is this node that I've transformed into randomly into space, wherever it is, by default, the match size is going to put it at the origin like this. Now, what's quite nice is there's a second input. And what it does is it takes the bounding object of the second input and it will utilize that. So I'm just going to delete this one. So if I take this grid that I've created, for example, and this grid is just also randomly in space, I can plug this into the second input and you'll see immediately, well, now my paver is actually centered within this grid, and wherever I move it, it's lining up. So that's quite nice. And what we can do is take it a little bit further on the match size. There's a couple of options. You know, we can do offsets and stuff like that. But there's also the scale to fit. And the scale to fit is quite cool. What you can do is just turn off this uniform scale. And you can see immediately what's happening is we're scaling the entire paver. I'll go into wireframe mode. You can see there's a paver. And it's scaling to fit this grid. So that's quite nice. Now that gives us a bit more interest. The only problem is it's flat. So what we can do is just disable the scale on the Y position, which is our up, and we disable that. And now we've got our paver height back. So we're just essentially squashing and stretching it to fit this. Now, what's really nice about this as well is that this is still a piece of a packed geometry. So this is one point and it's taking the boundary or the bounds of this pack primitive and scaling it into this match size. So I don't have to unpack it first and lose my efficiency. I can just take this packed piece of geometry and I can scale it up and down and move it anywhere in my scene. And, you know, it works really nicely. So now how can we do this and apply it to, say, this walkway top, for instance, like this? Well, what we can do is we can actually use this, we can use a for each loop. And this might seem complex, but it's not entirely that bad. So what I've done is I've taken my grid, I've done a sweep on here, and the sweep node gives me a couple of options of, let me turn off my point number display. And let's unreference this jobby. So I've set my shape by default. You will get this error and it's looking for a second input, but you've got these sub options you can set to round tube or square tube or ribbon. And the ribbon's quite nice. It gives you a flat plane. At the moment, the primitives are reversed. That's why they're blue. So I can actually put a reverse SOP on here. And you'll see when I select that now they become gray and now the bottom is blue. So that's the correct orientation for us to look at. And you can see now we've got individual primitives, and these primitives in between here are controlled by this resample. So if I increase or decrease them, I can get them, and let's try and make them squarish, something like that. And then we've got the sweep columns, and we can change the columns, amount of columns. At the moment I've got 2, and then we can control the width of the ribbon as well, which is quite nice. So going back to this for each loop, what we can do when you drop a for each, you can go for each primitive, and it will give you exactly this. And what it's doing is it's targeting each element, each primitive of a piece of geometry. So if I just view this, if I press information on here, you can see, I've got quite a few primitives, and just looking at this, it's giving me, well, this would be a single output. So if I view this, you can see it's got that single primitive. At the moment, I've actually set my, by default, sorry, I've set my pass, and you can set the single pass. So if I uncheck this, you can see now I've got, let's just middle mouse here again, 34 primitives. And over here, you can see listed 34 primitives. And this one over here gives you the previous piece. So it's saying 33, but there is 34 in output. And like I say, you can actually set this to single pass. So if we just template view this so we can see our geometry, and I can cycle through each one, each single pass. They're actually ordered based off their primitive number, which you could randomize as well. So there we go, we got each primitive. So now what can we do with this? So now that I've got the ability to get each primitive, I can essentially take my match size and I can use that. Each of these primitives, if I go here, got this primitive, I can plug it into my match size. And as soon as I do that, you'll see now my match size is included in this for each loop. And if I view that, you can see now my paver is locked into that scale of that primitive. Now what's quite nice about it, because it's in this loop and the output of the primitive count here is using the input as the value for iterations. If I just connect this here, even though I'm outputting a paver geometry, a packed paver geometry, if I view this and then I can cycle along, and you can see I'm getting, untick the single pass, it will give me all my pavers. And now we copying all those pavers to the geometry. And if I go back to my sweep and adjust the width, we'll go to this resample and I adjust that. They're copying and scaling into that area. Sometimes the scale obviously isn't ideal. You've got, a little bit of stretching and stuff. But with a lot of variation and stuff like that, we can compensate and get away with a little bit of stretching. So we'll look at ways we can minimize that as we go. But the idea is to try and keep your primitive size sort of squarish, so you don't get too much stretching. Now there is one major issue. It's going to delete that, and that's that the match size doesn't take into account orientation. So if I look at this single one, actually just view the output and turn on my single pass again, and let's just go to a corner. This looks like a corner. Let's just ghost the reverse here, go a few higher. There we go, we've got some corner points going. Now as you can see, what's actually happening, if you look at this primitive, for instance, this is the primitive we copying our paver to. Just ghost that and keep the paver visible. It takes into account the bounding box of the object. So for example, if I use a bound SOP, just to give you a visual idea, basically that's what it's doing. It's taking this bounding box and it's copying my paver to that bounding box size. So it doesn't see the orientation of the paver. It just sees the bounding box size of the paver and it matches that position, size, and location. So that's not ideal. So we need to figure out then a better method for actually doing a little bit of orientation. So we're going to be utilizing this method of the match size, but we're going to be taking it a step further, and we're going to be utilizing some of the tools that actually come with our rigid body dynamics setups. And don't worry about the nitty-gritty now. We'll get into that as we start building these walkways. So I just wanted to take you through some of those ideas and kind of, start letting you think about maybe a possible solution. If if you know Houdini, then maybe you have some ideas in your head. And but I'll show you the solution that I came up, the final solution that's based around this concept, and we will get to that when we start building our walkways. So next, I just wanted to take a look at the idea of using, our instances. So I've basically taken my walkway setup. I've drawn a whole bunch of curves here just to create a few on top of each other, just to create a render visualizer. And what I want to do is just isolate the tops. So I've got all my instanced pieces of geometry here. If I'm middle mouse here, I've got 413 packed primitives. And on this side, I wanted to illustrate the idea of just doing a textured version. So I'm isolating the tops and just doing a UV map on them. That's how my UV map looks. And then we can compare at render time what the difference would be without, too much additional work from a texturing point of view. Obviously, a texture solution we could spend a lot more time and work and get variation on, but this is obviously just a simple example just to give you an idea of how much variation you can get with the play on light and stuff like that when you're using actual geometry. So I'm going to go into my LOP setup. This is my Solaris here. I've used the separate node just to keep it contained to this scene. I can double click to go inside, and then I've got a SOP import that's importing my geometry, and this is my one with the UVs on. And then I'm doing a Copernicus stone floor that I'm assigning to it. Just have a look at that geometry. So, or not geometry, the actual shader build. So that will be sitting here. Sometimes it doesn't zoom in very nicely. It sits in like 3D space, so it's quite strange. But there we go. That's a single tile of the actual Copernicus shader build. It looks really nice, nicely detailed, and yeah, it's got some nice variation when you pan the light around it. So now let's apply this to my walkway surface, and I'm going to go and view the camera here. So let's just click on here and view camera. You can also drag and drop your camera onto the viewport if you didn't know that. That's quite handy. Just make sure you're viewing it. If you're up here and you try and do it, it's not going to work because the LopNet doesn't see the camera yet. You've got to view it and then you can drop it on. You see now I'm looking through camera 3. And now I'm just going to switch to my Karma XPU render. Give it a moment to think here. And you can see, let's just expand this. I've got some basic light on. So if I disable the light as a Karma physical sky, let's just pan around here a little bit closer in, and we can see our displacement working. And let's just view with the lighting on again. So it doesn't look too bad, but like I say, it's quite flat and repetitive. So we'd need to create a lot more work shader wise to get this to start looking a little bit more natural. At the moment it just looks like a tile pattern, and which isn't bad, depends on the look you're going for. But yeah, like I said, it's very flat and you're not getting very nice lighting. Now on this side, what I've done is I've brought in that displaced or the actual geometry. So these are my pavers that are unshaded, And you can see I've got, all this variation with these bits and bobs on. And I've just taken this stone floor material and I've assigned it to it, but without using the displacement. So on the quick shader setup, I've disabled the displacement input. So I've still got textures on it and my, my roughness and stuff, but there's no displacement or anything. So it's just purely mesh that it's rendering. And then let's just put our comma physical sky on, and you can immediately see we're getting some really nice breakup and detail across everything, and things start looking, you can't really see repetitiveness in the setups at all, because there's so many different pavers here. Well, there's not a lot, but they're all scale differently, and they're rotated at 90 degrees randomly. And we've got these separate components here that would be shaded differently at the end of the day. And we can add, what we will do is we'll be adding, as we go to individual pavers, we'll be adding different densities into the shader, and that helps break up the variation even more. So just going back and looking through this camera, I'm going to view it, let that resolve a bit so you can see how nice that looks. And then let's just switch to this one and view that. And we can compare the two just by doing that and rendering it again. And you can see the difference is quite substantial. Like I say, we could probably spend a lot more time texturing and getting a lot more variation out of our texture. But yeah, conceptually, so the idea behind this was to create high-res geometry and how we're going to deal with that. And the other nice side about this is when we hand our geometry off to our animation department, we've got this height that's built into the geometry. With variation, we could do a proxy of this, just give the animation our proxy version, and they will know where the animation of the character's footing needs to be. If we had to just give them a displaced mesh, they're going to get this, and they're not going to know exactly where the animation needs to happen. So overall, it's probably a slightly better approach, I think, to have this control, and we can really, go in and start dialing in settings, and we've got a lot of detail to work with, and it renders really quick and efficient. So that's what I wanted to just show, the kind of thought processes behind a geometry-based version. Rather, we can certainly do some texture-based versions, and this is sort of in the areas that are more towards the back end that we don't need that detail. But to the most part, we want to do high-res geometry where we can. Hi, what I want to take a look at next is how we actually take our data that we've generated and how we're going to render it in Solaris, and what type of data we need to output and to get our display working, and what type of instancing we're going to use. There's a couple of different types. So let's have a look at that, just so we got a clear path going forward. So I've got this basic little piece of walkway set up. And then on this tab here has got my render information. So this is all my geometry. And like I say, it's got this proxy geometry built in, overlaid into it. And what I'm going to do now is just go straight off, and I'm going to go into this little LOPNet, which is Solaris. I'm going to dive inside here, double clicking. And immediately you can see as I've come inside here, that high-res geometry is gone, even though my SOP is actually pointing to that high-res geometry. Now this is really handy. USD automatically handles this information for us, and I'll show you now how we actually set that up. But for now, if I hit render, let's just do a bit of a XPU render here. You can see as I hit render, now I'm viewing my high-res geometry. Maybe we should have some lighting on here. So let's just put a comic physical sky, just so it looks a little bit prettier. And you can see now I'm rendering the high res, and as soon as I switch back to my Houdini viewport, I've got my highly interactive little low res setup going here. So this is really handy. Another thing you can do if you really want to, I'm just going to change the lighting display here, but you can actually view your render geometry in the viewport. Now, obviously, if you've got a lot of data, you don't really want to do this because it's going to slow down your viewport quite a bit. You can come to the sunglasses and you can click on the display render, and now you can see I've got that same geometry displayed, and then you can actually turn off your proxy, and that will turn off that underlying proxy. So now if I turn off my render, you won't see anything. Go back to my proxy. Now I've just got the proxy displayed again. Another way to view what geometry is what, whether it's proxy or render, you can actually come down here to your scene graph view, which is comes through on your geometry spreadsheet as well. You can click on this little gear icon, and you can come here and say there's a purpose, and you click on this purpose, and now this is your purposes that you can set up. So let's just expand this out a little bit, and you can see here I've got, it says defaults, but what happens as soon as I expand this SOP import, you'll see I have a whole lot of information here. And as I scroll through here, you can see there's some proxies, there's a whole lot of render tags, and there's some more proxies down here. So you can see as I even go here and I select in the viewport, let's just change this component to XFORM primitives. Let's click on one of these, and you can see, okay, I've selected that one, and this is indeed a proxy. Now, obviously, you can't select your render geometry in the viewport because we can't see it, so you'd have to turn it on. And just before I move on to how we set this up in SOPs, I wanted to show you how you actually set it up, kind of the default way in Solaris, and that's through this component builder. So the component builder is a little setup that SideFX supplies for us. And if I just type component builder here, it creates this little network for us. Now what I can do is I've got a couple of options on this component. I can use internal or external files or geometry, but for now we'll just keep it to default because that's the easy way to show you the setup. And I'm just going to double click and go inside. Now you can see I've got some outputs here, and with a little bit of some nice little notes attached to it. So the optional proxy here is our display, and that's what we'll use when we want to display our low res geometry. So for now, let's just do the old little pig head here, and I'm going to zoom in on him and say we've got this geometry. I'm just going to disable the shader for now, and we've got this guy going here. What I can do now is do, like, for instance, say poly reduce. Poly reduce. So I can plug this into my default. So this is my output. And if I go just quickly, if I go to this now, I can see I've got my pig head. Let's just turn on the wireframe so we can make sure we've got the high res. And now if I actually connect my poly reduce, and let's actually poly reduce this guy right down, so it's quite obvious. And I plug this into my proxy. Now when I go out to my top of my LopNet, you can see immediately it's displaying that proxy. And that's quite obviously quite handy. It's a quick setup, and it gives you an idea of what's going on. So we're obviously not approaching it directly like this. I've got a slightly different method, and it's actually a fairly simple method. And I'll show that now. So I'm just going to delete this out to clean up the scene a bit. And let's go up back to our geometry level. Okay, and then just selecting my render flag here again. Got some networks that I've just deleted a few things out just to simplify what we're actually doing. So got only some of my geometry. Some of this big components is proxy geometry. And then I've gone here and I've deleted out one of my pavers. And this is kind of the high-res paver as such. And what I wanted to do is take a look at the geometry spreadsheet down here. And what I'm doing is if you go to the primitives tab, you can see over here, right at the end, I've got this USD purpose and it's called render. And then on this side, I've deleted out some of this top proxy edges here. And again, if you come down to the spreadsheet, you can see it's called USD purpose and it's set to proxy. So that's really how we actually just assign pieces of geometry to our different purposes, is actually just using different names, and it's actually a string attribute. And we can simply set this by using this name sop. And by default, this attribute is called name, but we can just call it USD purpose. And I've set the name to render. And likewise on this one, I've got a USD purpose, and that is called proxy. So, and this could be, you know, any piece of geometry. So I'll duplicate this, and then I can set this to proxy, for instance. And now you can see that USD purpose has now become a proxy. And if I had to go into USD, it will show up in the viewport like that. So I can see there's render and there's proxy because I've renamed it now. So that's what I wanted to show just on that part, is how I'm actually setting it up. I'm splitting out inside my setup the two geometries with different name attributes. And it's actually quite a simple way to generate those setups. So diving back into my LockNet here, the next thing I wanted to look at was just simple shader assignment. So let's just view this shader setup here. And let's go hit render again. Yeah, and enable our sky again so we can see something that looks a little bit better. Okay, I'm just going to go out my render and go back to my viewport. Now on the assign shader, I'm bringing in a material that's set up in this material library. So don't worry about all this now. If you haven't used LOPS before, we'll get to this. I just wanted to demo this setup for you and some possible hiccups that you might run into. So the assign shader, you can click on this arrow and you can select an object in the viewport. So I can, for instance, select this. I'm actually selecting the whole object currently, but I wanted to just select the edges. So I can go down to this, select X forms, and then just select individual components. Now I'm selecting just this, and if I hit enter, you can see it's assigned a shader, and I've called this shader red, and I've actually set it to blue. So if I go into my material network, and I've got this render shader going to this, and there's a standard material X, and it's set to this blue color. So going back up to my lot network, now I'm going to hit render, go to XPU again, and you can see, well, it hasn't assigned the shader. And that's the one of the gotchas that I wanted to show you, is just something you need to be aware of. You can't just assign shader to this because this is just proxy geometry and it doesn't get rendered. So what you need to do is you need to actually assign the shaders to the actual render geometry. And in this case, if you wanted to do it in this method by selecting the viewport, you would have to turn your render geometry on. Let's turn the proxy off and then just select that. And now we can come in and, shift select and select a couple of these guys, maybe even some of this, press enter. And now you can see that geometry is got the shader assigned. So if I render now, you can see now I've got that blue on those pavers. Now that's obviously not an ideal way to do it because we don't want to have to switch to a rendered view just to assign shaders. So I'm just going to reset this. Let's go out my render, go turn off my render and turn on proxies. So what we can do in this case is we can actually either come here and we can select a bunch of things. So, scroll up and go, okay, I've got a paver, and you can click and you can drag into this network. You can drag your pavers. And this is one of my top pavers, by the way, that I know. And it will assign to that specific paver. So let's just hit render and see if we've assigned it anywhere. So there we go. I've assigned it to this specific paver. And this is an instance, by the way, indicated by this blue value here, but I'll get to that in a second. So what we want to do is actually select all our pavers that we want to assign one shader to. And in this case, we can just go here and I can hit star, just take away. So paver underscore star, which will select everything. And now that will assign the shader to all those render geometries. Now, if I go back to my viewport, you can see it doesn't look like there's any shader assigned, which is fine. We don't necessarily want to assign shaders at this level. One thing to note that if you do assign shaders as well to this level, things can slow down a bit when you're tumbling, especially if you've got high-res textures on. So sometimes nice just to keep it clean, and yeah, when you switch to your render, you've got your shaded stuff now. And then just going back out this, just to illustrate the gotcha a little bit further, the same applies if you perhaps wanted to move something around. So I'm going to select this and I'm going to hit transform, and my handle's a bit offset here, but I'm not worried about that for now. So let's just move this. Maybe we wanted to rotate it and move it down a bit. Just tweak your geometry out a little bit, mix things up a little bit once you've done your setup. And you could maybe do that, but the same thing would come in when you hit render. You can see now I've got my proxy displayed in my render. You can see that that render is still in the same location when my proxy is just moved. So in this case, it's obviously not ideal. You'd have to now come in again and go to your renderer, select the object or select both objects if you wanted to move them both, and then press enter. And now you would have them both moved. And now if I hit render, you can see now it's rendering with that transform. So that's just something to be aware of. I just wanted to point it out with shader assignment and with moving things around, that you will need to be aware of the differences between your display and your render time geometry. So I'm just going to go back out here. I'm going to delete this transform. I don't want it. And then I wanted to move on next is to the actual structure and the instancing style of things over here. I'm just going to go ahead and pause this render quick, or stop it. Yeah, as mentioned, we've got, this whole list of geometry here, and we can, select individual pieces, and that's great, especially if you wanted to come in here and you want to do maybe tweak stuff. But in our case, we don't really want to do that. We want to make all our geometry modifications at the SOP level, and then the LOPNet side of things is just really for bringing in our geometry, assigning shaders and lighting it and making it look really nice. So we don't need to have access to a lot of this stuff. And I wanted to find a way to simplify this look as well. It's just simplified so there's not so much information to look at. Like I say, this is one little piece of walkway, and we've got tons of geometry that we can actually see here already, and that's like really a little bit messy. So we wanted to see how to clean this up. But before I do that, I just wanted to point out that, like I said, these are instances, and in the SOP import, you'll see there's this prototypes. And if I expand this prototypes, this is actually my main object. So this is like paver naught, and that's getting instanced throughout the piece of geometry, and these are the instances of that paver naught. So you can actually come in here and you can actually assign shaders at this level. So for instance, if I go to my shader here and let's just assign this paver naught to my geometry here. It will assign the shader to the paver 0 that is scattered along the surface. So if I hit render now, you'll see now I've got, this is my paver naught, the scatter version of that. And then likewise, I could, maybe come to a different one just to see. And that's, you can see it's changed a little bit. Paver 9, it's over there. Or you can actually come in and select all of them and drag them in all. And now you can see I've got all those pavers selected. And they've got the same material assigned. So we don't need all these to be able to assign shaders to. We can come in and just assign shaders to our proxies, and we can actually again come here and just on our well, not our proxies, our prototypes. I'm just going to actually, sorry, delete all this, just drop one in and start. And now I've got assigned to all my shaders without having to actually even look at any of these individual ones. The prototype controls the actual shader and the look of the entire geometry. So with that in mind, is we could hopefully simplify this in a way to, remove some of this data that we don't really want to see. And there is a way to do that, and it's kind of the idea, possibly a little bit more how we would see a normal copy type scenario within Houdini. And we've got this instancing locknet that is built for us from side effects. And this does a bit of an instancing setup. And I just wanted to go inside here and let's just disable my render. And let's just view this. At the moment, it's giving me an error, but I've got this little pig head assigned to it. And let's just view that. And I'm going to have to create some instant geometry. And the instance geometry goes inside this instancer. There's a bit of a deviation for a second, but just to show you what the actual result looks like. Let's just drop a grid. And I want to do a scatter and align. And this is just scattering some points across this grid, like so. And let's just give it a random scale and maybe some random rotation. So I've got now 106 points. If I go out here now and view this instancer, now you can see I've got my little pig heads and they instanced onto this. There's, like say, 106 points, and they obviously randomly aligned and scattered across the surface. Quite easy and simple, but the main thing what I wanted to show you was actually in the network. You can see now I've got this really simple looking network here, and if I minimize my prototypes, there's actually no instances here at all. You can't select these or anything, but there is, if you expand the prototype, you'll see here's my little pig head, and there's only one object in here. And in this case, it's actually bringing in materials as well for me for each instance. So that's quite handy in that sense that it's very clean setup. And now to do this, we can actually do this quite easily, luckily, in our SOP import. So we're going to switch back to that now. So I'm going to view my SOP import. Let's just home in on the little walkway here. And again, we've got our list of instances here. And if I go here onto my properties here, and there's this primitive definition, if I expand this, there's a pack primitives here. And this is how we deal with the pack primitives when it comes into LOPS. If I click this to enable it, you can see nothing happens. And it just enables this create native instances. And this is exactly what these are, the native USD instances. But what I can do is I can change this to create point instancer. And as soon as I do that, you can see my whole network disappears. And now I've got this little instances icon. And if I expand this, I've just got my prototypes set up here. So that's a little bit cleaner for me. I've got some geometry that's here, that's the proxies, but these aren't actually assigned properties, so these shouldn't actually be here, but it doesn't really matter too much since they're proxies. So then we can obviously come in again and assign our material. Got our SOP import paver by render, and it won't be assigned to anything because the name has changed. It's just a sort of something to be aware of. As soon as you change your name in Solaris, this path has changed, so I need to update stuff. So I'm going to just go back here and then assign all my pavers, and now I've got all my pavers assigned and a much cleaner network. So this is the workflow that I chose to use for this project. Like I say, it's a little bit less cluttered in the long run, and quite then easy to assign your shaders to. And then yeah, just going back out here, we've got our normal setup, and again, it's very clean and very quick. And hopefully this gives you some insight to a bit of the workflow. Obviously, we will go through this step by step once we start generating it. Yeah, so let's move on and get started with our project. Looking forward to getting the next part going. Hi, moving on to the project setup components of the training. I've loaded up a fresh version of Houdini. Everything's reset to default, just so that we can kind of build the setup together and make sure we're all on the same page. What I'd like to do first, and this is what I usually do if I get a new version of Houdini, not specifically a new build, but new versions, the directory structure changes, so we need to reset some of the defaults. But what I'd like to do is go to my file and go file open. And now you can see I'm sitting on, I've already, browsed to my the Rebelway directory where I store all my Rebelway projects. And what I like to do is click on this little plus button, and that gives me a shortcut to my Rebelway. Very handy to have. So for instance, I could go to my fundamentals project and I could click here and then have that directory, and then perhaps the FX challenge that I did as well. Click on that, and now I've got instant access to those three without having to browse to them. It just saves us some time along the way. I'm just going to go ahead and delete this with the little X button here and keep my Rebelway one open here. And I'm just going to go ahead and click cancel. We're not opening anything. I just wanted to set that, and that will be now set in the environment variables for a specific version. I'm going to click cancel, and now we can have a look at the actual project setup. So I'm going to go back to file. I'm going to go to new project. Let's just bring this up over here. And then what I want to do here is go to that directory. So I'm going to click open and then go to my Rebelway drive. And for now, I'm just going to hit enter. And as you can see now, what's happening is it's giving me this project path to Houdini projects. But up here, there's a project name and it's different to that. So what's actually happening is if you look at this $job, this is our variable that's been set. It's set to my Rebelway directory. It's creating a new project and then a new project again, which is kind of a little bit strange. And I don't really want to work like that. I don't want to create a project in a project. So in fact, what I want to do is I just want to use my Rebelway directory and then give myself a project name. So in this case, I'm going to be calling my project 3D artist, and I'm going to call this training on my side. Perhaps I should spell that correctly. And then this is obviously, you can change the name to whatever you want. But I have a project already set up, and it's set up for the trailer. So I just want to make a differentiation between the two. And moving down to this directory structure, what I wanted to point out first, that these names here don't really correlate to anything. This is just like a preset list of names. You can used to populate something, but they don't actually point to any variables or anything like that. So for instance, if I wanted to change the simulation name to test, it will still just, it will create a directory called test, and there will be no simulation folder, but it's not related to anything. It's just a directory creation setup here, like a batch directory creation setup. So we can leave that out. I actually don't want a simulation. And then, yeah, just so that's a little bit clearer. Now what I want to do is just disable some of these and maybe change some of the names. So I'm going to leave geometry, HDA we'll leave. This is obviously project dependent. A lot of the time when you're creating HDAs, you're possibly going to be saving them to the default Houdini directory. But if you want to save them specifically to the project, you can do. In my case, because I'm doing training and I'm distributing the training material, and when I'm doing rendering, I'm sending it to the RoboWare render farm, so I need to have my HDA within the project. So I'm going to leave a HDA folder where I'll save my project-based HDAs to. And then we've got this Alembic folder, and like I say, we're going to be bringing in some animation later on towards the end of the project, animation that's done in Maya. And these are actually, it's a mixture between Alembics and FBXs. So I'm actually just going to change this name from ABC to anim, anim like that. And then I can just store my animations that are received from the animator in this directory, not being specific to Alembic. Textures I'm going to keep, even though we're going to be doing megascans textures to the most part. If we find something else we like, we can dump it in here, and so maybe we can have some HDRs in here that we might be using. And then renders we'll keep. Flipbook, now Flipbook, I don't specifically like this name, and the reason for it is because it says flip, and it just makes me think of the flip solver, so it's a little bit confusing. As I do a fair amount of simulation work, I don't particularly like this name, so I'm going to call this captures, and kind of a little bit more of a reasonable name, I think. And then scripts, we're not going to have any external scripts. I'm going to disable that folder creation. Composites we can keep. We're not going to be doing any audio. And then videos I'm going to disable as well. And the reason for this is if I generate flipbooks, what I do is I generally export them as videos. So then I'll be putting my videos in the capture folder. So it would be like a double folder that I wouldn't really need. And then desktops, I'm not going to enable. There's no real reason to have a custom desktop within a project unless you really want to do that. I don't see a reason to do it. And the last thing what I want to do within this setup is, as you can see, there's no directory to save your actual Houdini file. And I like to create a HIP directory for this. And that's where all my HIP files will go. Now, just since we're doing training and it's done on a weekly basis, what I want to do on my side is I want to actually add a week name to the HIP. And since this is a directory creation little tool, actually, what I can do is I can actually just do a / and type week_1. And just for example, just to show you that you can do this, I'm going to do week 2 and week 3. Obviously, we're going to be doing, roughly 8 weeks. But I don't have space to do that. So I'm going to just enable these. And then there's 2 other directories that I actually want to create. And since I've got some space left up here with directories we're not actually creating, I am going to enable this. And what I want to do is I want to create a USD directory, and this will be where we exporting all our USDs to or when we go into Solaris and rendering. And it's nice just to keep your USD and assets within this kind of structure. Like we can actually possibly do a assets folder as well, like so. And this will just allow us, to put specific things into that directory. And then the last thing I want to do is create a mega directory. This is not entirely necessary, but it might come in handy. Actually, I'm just going to leave this in lowercase, and I want to put this one in lowercase as well, rather just a little bit cleaner and more consistent. Although, like say, the mega scans, we might not use this directory because we're going to be using an actual mega scan, the bridge mega scans. But in case you want to copy stuff here to move your project around that's specific to this project, you might want to create this. So I'm just going to leave it for safety. Let's just check if everything's correct. I've got my training folder set up. Everything looks right. So I'm going to hit accept. And now, obviously, we don't see much happening. So now if I go to File Open and have a look at got my 3DA training folder here. And I've got my directories I've created, captures. I've got Geo, HDA, Mega, USD. And if I go into my HIP directory, you can see that I've got a week 1 folder, a week 2, and week 3 folder. So that's quite handy. What I'm going to do now is just first things first, do a save as, and I'm now in my week 1 folder already, and I'm just going to save a start here. And this is not entirely necessary, but it just gives you quick access to, when you're going to File Open and you've got your project already, in this location. So then looking at that, we've also got a set project and we've got recent projects. So if you want to go and change your project, you can just go here, click on one of these and hit accept. And I'll show you in a moment what that does and why you'd want to do that. Next, I want to have a look at my environment variables. And this is obviously also linked to our project and our Houdini file. So what we can go to is go to Edit, and we can go to Alias and Variables. And if we have a look here and we go to the second tab, the variables here, you can see at the moment I've got this HIP file that I've saved, and it's pointing to that directory. Then I've got this job set up, and this is my project path. And so we can use this $job as a main component to quickly source where the files are sitting. So what happens if I change my project? So if I go set new project, and for instance, I go to my fundamentals, hit accept, and now if I go to back to my aliases and variables, now you can see my job path has changed to the fundamentals. You could quite easily come in here and change this manually as well. But yeah, I just wanted to show you that's what the main reason for setting the project would do. If I go back here and I go to my 3DA training, and let's go back and see if that one works. So now my job variable is set back to that 3DA training. Okay, then there's 1 or 2 extra setups I want to add to my variables just as some nice shortcuts. And the one I want to do is my USD. So let's do uppercase USD. And then as soon as I click away from that, you'll see this site clears out. And what I want to do here is obviously point to my project. So this is the project. So I'm just going to copy this and then go back here. So I need to do my USD again because I didn't enter that. And then I want to paste my project path and then just type USD here. And then once I've done that, press enter on the keyboard and you'll see it get populated within the setup here. The next one, what I want to do is I want to create a shortcut to my Megascans directory that we're going to be using. And in my case, I've got my Megascans also in my Z drive. So I'm going to bring up my Explorer here, and you can see I've got the Z drive Megascans. So what you can actually do is right click on here, you can copy address, and then just go back here. So I'm going to create a mega in uppercase, just for my environment variable, click away from it, and then I'm going to paste my directory here. Well, it didn't paste properly. Let's just go back to my copy address. Let's copy it twice just to be sure. Okay, no, it did do it properly. I just wasn't paying attention. And it's created it there. What I actually like to do now is you can see it's created the slashes in the wrong direction. So what I need to do here is change the slashes to this. And then what I want to do as well is just shortcut it even more. So going quickly back to the directory structure here, and I should have copied this directly, but you've got this downloaded, and then you've got surfaces. So we're just doing surfaces. This is our concrete and all that kind of stuff. All your 2D textures go here. If you're downloading other assets, they go into obviously your 3D, but we're just going to be dealing with 2D setups. So I'm just going to copy this address again, and let's just paste this here, and then we make sure we change all our slashes to forward slashes like so. And now we press enter, and you can see now we've populated that directory with the correct setup. So we've got the mega, and now we can use $mega, and it will give us direct access to our textures. So I think that's it for the environment variables. Just check we've got our job, mega, and yeah, USD. So that's good. We can hit close here. And then the next thing, what I want to do before we go on any further, I actually want to set the frame range to a different frame range. And the reason why I'm doing this is because the animation that we're going to be receiving starts at the frame 1001. So I'm going to set this, and I don't know entirely, well, possibly we don't know how long the animation is going to be. So I'm just going to give it a broad range for now. So we're going to go 1001, you start at, and let's just make this 1300, or let's make it 400 or 500. 400 is fine. Like so. I'm going to leave the frames per second at 24 frames per second. That's what we're working at. And now the reason really why we're doing this frame range setup, and this is often done in production houses. We used to use it all the time. And what happens is when you're doing shots for a project, like a big production movie or something, you want to have leeway to be able to push and pull around the area. So you call it your kind of top and tail of your shot. So starting at 1001, perhaps you've got a 10 frame, top or the handles, we could call it as well. So you've got 10 frame handles on each side. So your shot would actually start, technically the animation would start at, so sort of 990. And you could set it like that then again. So instead of going, if your frame range was set to 1 every time, you would now have to start going negative frames to try and compensate for stuff. And this comes in quite nicely also when you're doing simulation. You don't want to pre-simulate something. I've done like flip simulations, like of a river or something, where you're going 100 frames. Now you've got like a minus 100 on your timeline. It just doesn't look quite nice. And so instead you can go, frame 900 as your pre-roll. And then when you get to frame 1001, you've kind of where your simulation almost starts as the shot starts. So most or a large amount of production houses are generally you'll find start at this frame range. 1001 is just quite handy. And then, yeah, so that's it. I think the rest is fine. Default, we can hit apply and close this. You can see we've set the frame range correctly down here. Okay, to start a new shelf tab, we just want to go to this little plus icon up here, and we're going to go new shelf tab, and let's call this Rebel Way. In my case, you can call it obviously whatever you want to. I'm going to copy and paste the name just because I'm a little bit lazy, and then I'm going to hit accept, and you'll see now we've got this shelf tab that's empty. There's a few ways to add things to it, but to the most part, what we'll be doing is dragging and dropping onto it, which is quite handy. So if I just, for instance, create a geometry, I can drag and drop it up here, and you'll see now I have this shelf tool, and if I click on it, it creates that geometry tool. Essentially the same thing, but that's what it's doing. So another thing you can actually do, which is quite nice, is you can have multiple nodes and you can drag them up here. So if you've got a little setup, and this is where the lines blur with the new recipes tool, we can, for instance, let's just do something simple. I'm going to do a null, a copy, let's say copy points, plug this here like this, and maybe let's just do a torus or something, good old faithful torus, and let's just do another null just to have some more nodes available to us. I can select all these nodes and I can drag them onto the shelf tool. That's going to come up with a name. You can set an icon, and then it's just going to obviously give me a specific, like a generic name that it's trying to figure out. And we can obviously change this as we want. So we can maybe call this copy, or let's call it my copy just for clarity. I'm going to delete this afterwards, but obviously this is just a demo, and I'm going to hit accept. And now you'll see I've got this my copy set of tools here. If I click on this now, it's going to generate that instantly for me. And this is really just building a Python script with creating all these nodes at once, and quite nice because if you want something with custom parameters, and you copy it into here or drag it onto here, it's going to populate your scene with those parameters. Now, the only thing what I find doing this is, say you've got a setup and I've got, say, my grid coming in with the scattered points, and now I want to create my copy setup, and I click on this, and you can see, well, what's happened is nothing happening. Now, it's actually just takes the, runs the Python, and there's a part of the Python snippet that would say, put it in the next best place. And what it's actually doing is it's putting it kind of at the center of the scene here. And this is obviously not ideal. So another way we can actually access this shelf tool without even going here is you can actually find it in the tab menu now that you've created it. So if I go type there's my copy, and I can click on it and place it over here. Likewise, if I just click on here and hover over and do the same thing, my copy, it should, well, it doesn't connect, but you can see it places it exactly where you want to. So that's really quite handy. Now I've got my little quick copy to points, and yeah, we can obviously quickly build a scene like that. So the other way to create this system, and like I say, the newer kind of set of tools, we can use the recipe setup for this. And this is actually also quite nice to use. It just depends on, whether you want to populate a shelf or not. We're going to use the shelf tools, and you can actually create a recipe, and you can actually add that recipe in a bit of an awkward way. You can add it to this set of tools as well. I'm just going to go ahead and delete this. Let's keep this. Maybe we'll just change the settings a little bit and make another null just to make sure it's a different kind of setup. Obviously, this doesn't mean anything. It's just for demo purposes. But what you can do is select all these nodes, and then you can right click on it, and you can go to recipes, and there is save selected items as tool. save items as decoration, or save node preset. These are all obviously different things. I'm not going to go through a lot of them. We just really want to create a tool at the end of the day. But the decoration one is quite interesting. It's almost like if you've got a specific node selected, and then you can, for instance, the copy to points, I could have a set of nodes built around it if I've created this. So if I just drop a copy to points and then I load a decoration, it will populate some nodes around it that I've got kind of preset. It's quite a odd workflow, but interesting to the same point. And then we've got our node presets. So like I say, I've modified this, and we can go to recipes and we can save node preset. By the way, you can also go up here on this menu. There's a little spoon there, and we've got an example, but we can save node preset, and you can see it comes up with this nice little dialog, and it will show you the values that's been changed, and you can give the preset a name. So let's call this my torus. Hit save. And now what I can do is if I drop a new torus, for instance, I can come back to my recipes, and then I can just go to my torus, and you'll see the parameters change to that specific one that I've set up. You can obviously also, if I right click on this and let's say revert to defaults, now I've got my default torus. You can come down here, right click menu, recipes, and you'll see it in this list as well. And I go my torus, and it will automatically set up that value. But the main tool that I wanted to really show you, which is quite nice, is if I select all of these points, and then I can right click and I can go to recipes, and I can save selected item as tool. And this is really quite handy. It comes up with this nice little cute dialog that's got all the nodes in. And let's have a look at some of the options that's available to us here. So just kind of briefly covering some of them. The first thing here, we've got this anchor node, and this is kind of the center node that will be selected or created first. So what we would probably want to do is use the first input as our anchor node. So I can go, obviously I haven't named this very nicely, but we could go to our null 6 and use that as my anchor node, and you'll see that one gets highlighted up here. And we're not going to look at too much of this. Is all fairly generic stuff. We've obviously got a title, so I can do this, call this now, I'm going to call this I'm going to underscore it this time, so it's different from the other setup shelf tool we created. My copy setup, let's just make it quite a different name. And then what's quite nice is it creates a tab menu by default, submenu with the recipes. So all your recipes will go into this setup here, and you can change this name and make your own custom one as well. It's got a default icon you can change, so you can change this to anything, your spoon maybe, for example. And then we've got a save path, and this is where, as mentioned before, you can customize this, and you can go, okay, well, I want to save it to my default path, which is generally your home directory, or you can save it to your job OTLs directory. So in this case, that's what I'll do. And this will just, I don't have OTLs, but it will be created for me instead of HDA. HDA and OTLs is pretty much the same thing. Yeah, I think that's it. We've got a name, we've got set to the directory. You can see the working directory that it's going to save to. And obviously my extension here, you can see, is not .hda, it's .nc, because I'm using an educational license. But I'm just going to hit save here, and let's see what happens. So now what I can do is I hit tab, I can go down to my recipes, and you can see I've got my setup, and if I click on that, you can see there immediately, without dropping anything, I've got this null icon. I'll click on this. You can see now it's dropped the points around there. So this is quite handy. So if I've got my grid example again, and I go here to recipes, my copy, and then immediately I've got that set up connected like that. What's quite interesting though is you can see the name, obviously because this hasn't got a specific name to it that I have, like this was null 6, and because I just left it at null, it's obviously appended the name to something else. It's quite handy. Now the other thing we could possibly do is maybe we wanted to add these recipes to a shelf tool, and that's not entirely the most convenient way to do it. I wish you could, drag them on, but obviously when you create this recipe, it's creating these nodes and it's not actually giving you access to the HDA or the OTL as such. So what we can do is go to this and right click on this and go edit shelf. And you can go on the second tab where it says tools. Now you can see, since I named my recipe with the underscore, my copy setup, you can see it's right at the top of the list here. Otherwise you would have to, if I just called it my, I would have to manually scroll down to my. That's just a little bit inconvenient. So for this sake, I just put the underscore over here. And I know it's this one over here. I can click and select this, hit accept, and I can see that my copy is now on the shelf tool. So you don't have to necessarily tab to it. And I can just click on this and it will generate that recipe for me over here. So that's just another way we can use recipes and the shelf tool together. I'm going to go ahead and just delete all these. Obviously, I don't want to use these are just tests and we're not going to be using them in the project. Just delete, and delete this out. Let's go up here. All right. So now we've got our clean setup, and I think that brings us to the end of the project setup. Just checking, we've got our shelf tool, we've got our project, our environment variables. So everything looks good to go. Let's get started with the next section. The next part of the project setup, what I want to look at is modifying the desktop a little bit. As you can see, we've got quite a lot of stuff going on. We've got all these tabs and stuff. So we just want to clean that out, create our own little desktop and streamline things a little bit more. So we're going to go up to our build here. And first of all, what I want to do is I'm going to go to my desktops manager. And you can see we've got a whole list of all these desktops. So we can actually hide those as well, so they don't appear in this list, and just cleans things up even a little bit more. So you can go hide. So I want to hide everything really. Got this grooming, we can hide. We can hide this. Labs, we can hide. Look diff, we'll hide. It's old. Hide the modeling output. Solaris, we can leave for now, just so we can look at them possibly. And then we're going to hide those, hide the technical, going to hide all these ones. We don't need any of them to show up. And then what I want to do on this build is I actually want to duplicate this, and I want to use this one that we're going to customize. I'm going to call this build underscore JS just to underscore it with my name. And we're going to save this one and hit accept. And now let's go up here. So you can see we've only got a few little desktops. I'm going to switch to this one. And now we can see we've got some changes. Obviously, I've saved this once before, so it switched my background to black. And this is just pushing D on the keyboard, the display options for the viewport, and coming up to background and switching it from light to dark. I prefer working with the dark background. Makes the geometry stand out quite nice. And when you're switching to like a lighting phase, it's like this, not this big contrast jump between things. So I'm just going to close this and leave that like that for now. And then what I want to do is just remove some of these additional tabs that we've got going over here. So we've got like this performance monitor. Sometimes it's quite handy to use, and it is good if you're trying to problem solve, but for this project, we're not really going to be using the performance monitor. This take list is really old. This is, mostly for the old mantra style rendering. So I'm going to remove that. I'm going to leave the parameters. And then I want to close down this tab, close pane, all tabs. So now I'm just left with these two. Let's move this over to the side. So now I've got this object network here, which is just my network here. So there's no parameters, obviously, but what we can do while we're hovering our mouse over here is hit P on the keyboard. Maybe we should just create a piece of geometry. So I'm going to just create a piece of geometry here. Oh, this is actually set to parameters, sorry. So we need a network view, and let's hit P on the keyboard. You can see it comes up with this thing that says no operator selected. So if I create a piece of geometry, for instance, let's just create a geometry node, and now you'll see my parameter pane pops up. So that's just a slightly cleaner way of doing it, and you can expand this in and out as you want. So yeah, it's not quite nice to have more real estate in your network editor, and then we can divide that between our viewport as well. The other thing, what I want to do is just come out and clean some of this up. So we've got this animation editor and rendering. So we don't really want the animation editor here. The render view we're not going to use. This is like our old mantra, or if using maybe like an older version of Arnold or something, you would be rendering here possibly. And then composite view we don't need. Motion effects we don't need. The geometry spreadsheet, having it here is a bit odd, so we're going to remove it as well. And now you can see we've got far less information going on. Now I'm going to keep my shelf tools up. There's some handy things obviously we use along the way and to get quick access to it. So I just keep that open for now. And then the next thing what I want to do is I want to actually create my geometry spreadsheet down here. So I'm going to come up here, I'm going to split the plane to top and bottom, the pane, sorry. And we'll have this double pane now. So what I need to do is right click on the scene view, and I need to go down to inspectors, and I want to change this to geometry spreadsheet. So now I've got my geometry spreadsheet sitting like this, and my parameters, and I think that's looking all good. So what we can do now is go to my desktop, and we can save current desktop. Okay, that's great. So just checking, we go to the build, it looks like this. Now we go to my one, and it looks like this. Obviously you can arrange this exactly how you want. It's entirely up to you. You can even change the colors to custom colors if you want. But that's just personal preference. I like it quite dark like this.